This is the lecture for lesson 18. So this lesson is all about inverse functions, and the first one is we're going to discuss how to create inverse function ordered pairs. And then if we're given a function or a table, can we find the inverse function values? So an inverse function, if we have the original function, its inverse is f to the -1, like that, x, but it's read the inverse of x. We don't read it as f to the -1. What it does is it's flip-flopping the x's and the y's. So what was the x is now the y, and what was the y is now the x. And if we do a composition of functions here, f of g of x, we should get x. And if we do g of f of x, we should also get x. For a one-to-one function, we have f of 5 equals -2 and f of 3 equals 1. Find the input and output values of the corresponding inverse function. So what we said was the inverse function is going to flip-flop the x and the y. So the inverse of -2 is going to give me 5. And then if I flip-flop these, the inverse of 1 is going to give me 3. So we'll do the same thing for number 2. We have our one-to-one function, f of 7 equals 9, and f of -6 equals 2. So if we want to find the inverse, flip-flop them. F inverse of 9 is going to be 7, and f inverse of 2 is going to be -6, because we just flipped them. Now we're going to find function values and inverse function values from a graph. The first one we've already done. So to find f of -2 means you go to -2 on the x and find where the graph is. And the graph is at 4. So this is saying, what is y when x is -2? When we're looking at the inverse function, it's asking what is x when y is 2. So we're given the y value now. We need to work backwards. So now I need to find the y value of 2, which is here. And the graph hits that height at an x value of -1. So f inverse at 2 is -1. Let's try another one here. G of -3. So what is y when x is -3? So x, -3, the graph is right there at 0. For the other one, it's asking what is x when y is 3, because now I have the inverse at 3. So I need to find the y value of 3, and my graph hits that height over here, which is an x value of 5. We can do the same thing with a table. We just need to make sure we're reading carefully. So f inverse of 4. So this means y equals 4. So f inverse is 4. That's right here. What is the corresponding x value? 0. Okay, f inverse is -1. So that y value is -1. The value that gave us that was 2. All right, that is different than if I said, what is f of 1? Well, f of 1 means x equals 1. So let me do that in a different color here. So x equals 1 spits out 5. So you just have to make sure what you're given. Are you given f or the inverse? If you're given the inverse, you find it in the y column and go back to find your corresponding x value. We have another table here. This should say g, and because it is saying our function is g here, so you can correct that if you want. G inverse of 0. So the y value is 0 when x is -1. G inverse of 2. So we have a y value of 2 when x equals, 4. So now we're going to be given two functions and asked to verify if they are inverse functions. And we are also going to be given one and be asked to find the inverse function. So the way to check that you have inverse functions is to plug the one function into x for the other function. You can do g of f of x or f of g of x, but you must always get x. If you get anything other than x, you do not have inverse functions. Problem 1 says our first function is 6x, and the second function is x over 6. And we want to know, are these inverses of each other? So you only have to do one or the other. You don't have to do both, but I am going to show you both just so that you can see. So let's plug x over 6 in for x here. So let's do f of g of x. So in place of x, we're going to plug in x over 6. So instead of writing 6x, I'm going to do 6 times x over 6, which is going to make 6x divided by 6, which is just x. So that way we know works. We can also do the other way if we wanted to. And that is to plug this one into x over here. And you're going to see that we're going to get the same thing. So instead of x over 6, I'm going to write 6x over 6, which is what we just had, is going to be x. So this one was g of f of x. But as long as whichever way you go, you get x, yes, we have inverses. So the next pair is 4x plus 9 and x minus 9 all over 4. So let's plug this one in to x over here. I'm going to come down here. So instead of writing x minus 9, I'm going to do 4x plus 9, because that's taking the place of x, minus 9 all over 4. Now, I don't need the parentheses there. Positive 9 minus 9 is going to give me 0. So 4x plus 9 minus 9, that's gone all over 4. And 4 divided by 4 is 1x. So yes, this one works. And the last one here is going to be a little more involved. We got a little more work here. So if we plug this one in place of x down here. So we've got 2 over, instead of x, I'm going to put 2 over x plus 5. Then I also have a minus 5. So that's nice. The plus 5 and the minus 5 are going to cancel each other out, leaving me with just 2 over x. And we don't really like dividing by fractions. So instead of dividing by fractions, usually we multiply by the reciprocal. So that makes 2 times x over 2, which is going to be 2x over 2, or just x. So all three of these pairs are, in fact, inverses of each other. So how do we find the inverse function if we're given a function? Well, 3 easy steps. So step 1 is you're going to rewrite the given function as y equals. So that's the first step here. Step 2, you're going to swap x and y. So x goes in for y goes in for x. And step 3, you're going to solve for y. So this one doesn't actually go through and solve for y, but that's the third step that we're going to then have to do. We've got 4 examples here to work through. The first one, our given function is f of x equals 3x minus 1. So the first thing I'm going to do is change it to y equals 3x minus 1. And then I'm going to flip-flop the x and the y. So I'm going to make it x equals 3y minus 1. Now I need to solve for y. So I'm going to add 1 to both sides. So I have x plus 1 equals 3y. And then to get y by itself, I need to divide by 3. So x plus 1 over 3 equals y, which this is the inverse function. So x plus 1 over 3 is the inverse of x. All of the problems are going to follow that same process. So if we look at number 5, we have the function equals x cubed minus 1. So I'm going to start with writing y equals x cubed minus 1. And then I'm going to switch x and y. So x equals y cubed minus 1. In order to get y by itself, I need to first add 1 to both sides. So x plus 1 equals y cubed. And then to get rid of the cube, I need to cube root. So I want to cube root both sides. It's going to give me the cube root of x plus 1 equals y. And then instead of writing y, I have to write it as the inverse of the function. Number 6, our equation is y equals x over 4 plus 9. So swapping x equals y over 4 plus 9. I'm going to first have to subtract 9 from both sides. I get x minus 9 equals y over 4. And y over 4 means we're dividing by 4, so I need to multiply by 4 to cancel that out. That is going to make 4x minus 36 equals y, which means our inverse is 4x minus 36. All right, now comes the last one, which there's more than one x, which means there's going to be a little more work involved here. So our given function is y equals 2x minus 3 over x plus 1. If I switch x and y, x equals 2y minus 3 over y plus 1. So the first thing I'm going to have to do when I have more than one y like this is cross multiply. So when I cross multiply, I need x times y, so xy, plus x times 1 is x. And then 1 times this value, 2y minus 3, doesn't change the value. All right, what you need to do is get the y's to the same side and get the x's to the other side, or everything else to the other side. So what I'm going to do is I'm going to subtract this x piece over here. So I have xy equals 2y minus 3 minus x. And then I can move this y piece to the other side. So minus 2y to both sides is going to leave me with xy minus 2y equals negative 3 minus x. Now, what you're going to do is use factor GCF. So I have a y out of both of these pieces. So the only way to turn two y's into a single y is to factor it out. So if I factor out the y, I'm left with x minus 2. And then now I can get y by itself by just dividing by that x minus 2 piece. So I've solved for y. It is negative 3 minus x over x minus 2, which means the inverse is negative 3 minus x over x minus 2. What if they give us a graph? Well, we know that our points are just going to be flip-flopped. So there's 3 points graphed on this graph. They are -3, 0, -1, 2, and 5, 3. That's in the original function. So if we want the inverse function, we're just going to flip-flop these. So 0, -3, 2, -1, and 3, 5. So 0, -3, 2, -1, and 3, 5. And then you're just going to connect them. And there you have your inverse graph. So we have another one here. Again, they give us 3 points in the original graph. The original graph is -2, 4, -1, 2, and 0, 1, which means the inverse values are just going to be flipped. So 4, -2, 2, -1, and 1, 0. So 4, -2, 2, -1, and 1, 0. And it's going to look like that. So the way you know you've done it right is if you were to fold your paper along the diagonal here, they should be mirror images. They should fold on top of each other. That's how you know you did it correctly. And that is the end of this section, so feel free to start your homework.